So the next topic is acidic nature of carboxylic acids. Okay, so in the starting of this chapter, I have told you about fatty acids, right? Fatty acids, what are they? They are monocarboxylic acids, right?
Yes, ma'am.
And these fatty acids, what about their acidic nature? They are weak acids. Okay, and the acidic strength of these fatty acids, the acidic strength, it decreases with increase in molecular weight. Okay, if we increase the molecular weight, then the acidic strength of these fatty acid decreases. If I will tell you about the general order of this acidic strength, so it would be methanoic acid, then will be more stronger than this ethanoic acid, and then propanoic acid. Now, what is the cause of acidity of this order? We will be studying now. For example, I'm taking the structure of carboxylic acid. This is carboxylic acid. Okay. And another resonating structure, if I tell you, then it would be, we will migrate these ions, lone pair of electron, and we will be getting negative charge on oxygen and double bond with positive charge on this oxygen and this. Okay, so due to what are we seeing here? Due to resonance, the oxygen atom of this OH group, it acquires the positive charge in this structure too. Okay, and therefore we can say that the electron pair of OH bond is attracted by the oxygen atom. So what happens now? The OH bond, it weakens and it breaks the proton and the carboxylate ion. So if we do the dissociation for this, the dissociation will be, this is carboxylic acid, this is H2O. Okay, now this bond is getting weakened, because of which we will be getting RCOO negative, because of which we get a carboxylate ion along with hydronium ion. Okay, so this H plus, which will be released, it will be acquired by this H2O. Okay, and it will be forming a hydronium ion, and we will be getting a carboxylate ion. Now, if we draw the resonating structures for this carboxylate ion, it will be like this. This is carboxylate ion. This is the first structure, and the other resonating structure will be this one. So it will be RCO negative double bond O. Thus we see that this is the carboxylate ion, the resonating structures for carboxylate ion, and these are the resonating structures for carboxylic acid. Okay, so we see that both carboxylic acid and carboxylate ion, they are stabilized by resonance. Okay, or if we say that these carboxylate ions, this structure first and this second structure of carboxylate ion, they are more stabilized in resonance than these carboxylic acid resonance structures. Why is it so? Because here there is no separation between the positive charge and the negative charge. Here we can see that both positive and negative charges are there, but in the resonating structures of carboxylate ion, there is no separation of positive and negative charge. Thus we can say that the carboxylic acid, the parent one, is less stabilized by resonance, because the first and the second structure, there is charge separation. We can see charge separation, so they are not equivalent. But in the resonating structures of carboxylate ion, there is no charge separation, and thus it is more stable due to resonance. Clear?
Ma'am, why is it more stable? That part can you say again?
Yeah, because when we see the structure first, second, and let's label it to be third and fourth. Okay, now I will name the structure according to this number, okay, Roman number. Now if you see the second structure, there you can see that the positive and negative charge separation is there. Positive and negative charges exist. But if you see the fourth structure, okay, there only we can see the negative charge. Because of which, because of this charge separation in second, it is less resonance stabilized than the fourth structure. So we can say that carboxylate ion, the resonating structure from carboxylate ion, it is more resonance stabilized than the carboxylic acid one. Okay, the reason behind it, it is the charge separation. Okay.
But in the second structure, it is 1 is plus, 1 is minus. So the total will be 0, right? Same like structure 1.
Where it is plus in fourth?
No, in second one, I mean. In second one, it is plus and minus. So the total charge is equivalent to the first structure, right?
No, I'm not saying that it is positive and negative charge and addition on addition it will give 0. We are not adding here charges. I'm just saying that in the structure there is separation of positive and negative charges, because of which is making the structure to be less stable. Okay, in this case it is not like electrochemistry, we are writing a reaction and we are balancing the charge.
Okay, okay.
Okay, and in the fourth structure there is only negative charge, because this oxygen had a negative charge, so it donated the electron, so it would acquire a positive charge. It already had a negative one, so the cancellation of charge has occurred, because of which this oxygen has no charge on it.
Okay, ma'am.
Okay, so this was all about the physical properties. Now we will be moving to the chemical reactions which are associated with carboxylic acid. And this is the last topic from the chapter for carboxylic acid. Then we are done with the whole chapter. Okay.
Um, Ma'am, 1 second,
Yeah.
ma'am. Can you just scroll up once? I just want to read this screenshot.
Okay.
Okay, ma'am. Take it now.
Okay. Okay. Now the next topic is chemical reactions. First, we will be doing the chemical reactions which are involving the cleavage of OH bond. OH bond. It is the same bond that we have studied here. The cleavage of this bond. And if the cleavage of this bond occurs, it will give us carboxylate ion. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. So first is the reaction with metals. Reaction with metals. Okay. For example, we can take active metals such as sodium, potassium, calcium or zinc, etc. And these all metals, what they will do? They will liberate hydrogen gas. For example, I am taking a general reaction RCOOH and Na. Okay, so what it will form? It will form RCOONA. How has it formed? Now, what is happening here? This is the carboxylic acid. Okay, the cleavage of this OH bond is occurring. What is it giving? It is giving RCOO negative. Okay, then this Na metal, it is combining with this RCOO negative. It is forming RCOONA, and this hydrogen gas is being liberated here. Okay, similarly, we can take with any other metal. For example, I'm taking with RCOOH and I'm taking Mg. Okay, now as this sodium metal, it has +1 charge on it, and magnesium, we know that it has +2 charge. So if there is +1 charge, we will be taking one molecule of acid, and if it depends upon the charge of the metal, if it is the metal with +2 charge, then we will be taking 2 carboxylic acid molecules. And these two carboxylic acid molecules will give us the product like this, and hydrogen gas will be liberated. So this was the reaction with metals. The next reaction will be the reaction with alkalis. Reaction with alkalis. Okay. Now what happens in this? In this, the reaction with alkalis, we are getting salt and water as a product. Now I'm taking a general reaction of RCOOH and I'm taking an alkali, that is sodium hydroxide. I'm taking, we are getting the same salt, that is RCOONA. This is the salt part, and we are getting a water molecule. How are we getting this? Just see that we have this carboxylic acid, okay, and this NaOH. Okay, now cleavage has been occurring here. Now this Na part goes on to this and forms a salt, RCOONA. We are left with one H and one OH. Now these two, this NH and OH, it combines to form water. So these are the two products that we are getting. This is salt and water. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now the third reaction where the cleavage of OH bond takes place, it is the reaction with carbonates. The reaction with carbonates and bicarbonates. Bicarbonates. Okay. Now, Pranavi, can you name a carbonate? A metal carbonate?
Ma'am, sodium carbonate.
Yes. Na2CO3. And Joanna, can you name a metal bicarbonate?
Ma'am, NaHCO3.
Sodium bicarbonate. Okay, so I will be showing the reaction with these two carbonates and bicarbonates. How? For example, I'm taking a bicarbonate first. I'm taking RCOOH and I'm taking bicarbonate NaHCO3. Now we know that here also salt will get formed with salt, RCOONA. And along with this, we are getting CO2 and water molecule. Okay, if I am taking Na2CO3, Na2CO3, okay, sodium carbonate I am taking, then I will be taking 2 moles of this acid and I will be getting 2 RCOONA along with same CO2 and water molecule. So just remember that these two reactions are very important. The reaction with sodium carbonate and sodium bicarbonate. Okay, as a product you will be getting salt, and in both you will be getting CO2 and H2O. Only the difference is in the number of molecules. Okay, what were you getting in with alkalis? You were getting salt and water. What were you getting with reaction with metals? You were getting H2 gas with salt. So if you have noticed, then the salt product is common in all these, right?
Yes, ma'am.
Yeah. In first we were getting H2 gas, in the second we were getting water molecule, and in the third we are getting CO2 and H2O. So this was when we were doing these reactions, was when we were doing cleavage of this OH bond. Okay, this is the first type of cleavage. Now the second type of cleavage in chemical reactions we will be studying is the cleavage of COH bond. Okay, which bond? If carboxylic acid is like this. Now first we were studying the cleavage of this bond. Now we will be studying the cleavage of this bond. Okay, for this I will be taking 3 examples. First is the reaction with these reactions which I am teaching now, they can come as incomplete reaction type, or it can come as a conversion also. Okay, so understand properly which cleavage you have to do with which reagent. If you are given with PCl5, PCl3 or SOCl2, okay, if you are reacting a carboxylic acid with PCl5, PCl3 and SOCl2, then remember that you will be getting acid chloride as a product. How? Let's see. For example, first I am doing the reaction with PCl5. It will be, I'm taking acetic acid with PCl5. Okay. Now what you will be getting, we know that acid chloride we will be getting, and this is a 2 carbon compound, 2 carbon acid. So we will be getting 2 carbon acid chloride. It will be CH3COCl. Along with this, we will be getting HCl and POCl3. This is a most important product that we are getting. Okay, we will be getting POCl3. If we are doing the reaction with PCl3, okay, then we will be getting acid chloride CH3COCl. Along with this, we will be getting H3PO3. Okay, these reactions you must have studied in alcohol chapter also. Haloalkene or haloarine or alcohol chapter, you will be getting H3PO3. And the last reagent given to us, if we are reacting with SOCl2, then we will be getting acid chloride is fixed for both. We will be getting SO2 and HCl. In your previous chapters in organic chemistry, you must have noticed, you must have studied this reaction. This reaction for the formation of acid chloride from acid. It was most favored reaction. Why? Because both the products, SOCl2 is also in gaseous phase and this HCl is also in gaseous phase. So we will be getting acid chloride as a pure product because these both will be evaporating. Okay, clear?
Yes, ma'am. Clear, ma'am.
Okay. Now the second type where cleavage of OH bond takes place is the type you have studied many a times. It is by the formation of esters. If you have noticed, when we were forming esters from carboxylic acid, we were following an acid was reacting with an alcohol. In 10th class, you must have studied about esterification reaction, right? Where esters were forming using this, where acid was reacting with an alcohol. Okay, so what were you doing? You were liberating this OH from here and H from here. Water molecule was leaving the system as a byproduct. This reaction was taking place in presence of concentrated H2SO4, or in, we can say, in acidic medium. And what were you getting? And so note, see here that which bond is cleaving here? COH bond is being cleaved here, and you are getting an ester. Clear?
Yes, ma'am.
Okay. So the third type where cleavage of OH bond take place, it is the reaction with ammonia. Reaction with ammonia. Okay, what is ammonia? Ammonia is NH3. Okay, so when carboxylic acid, it reacts with ammonia. Okay, we are getting ammonium salts, and if these ammonium salts are heated, we will be getting amides. What is the formula for amide? General formula? Amides.
RCONH2.
Yeah, we will be getting amides on heating. How will this reaction proceed? Let's see. I'm giving a general method, general reaction. I'm taking carboxylic acid, then it is reacted with ammonia. We will be getting ammonium salt. How will we be getting ammonium salt? This NH3 and this carboxylic acid combines and it forms RCOONH4. This is ammonium salt. And when this ammonium salt is heated, I'm getting RCONH2 along with water molecule. Okay, let's take an example of a complex reaction. For example, I'm taking this. What was this? What is the name of this compound? What is the name of the compound? When two COH are attached to their adjacent position? Anyone? Then what is this? I have told both of you about these. Have I told?
Ma'am, phthalic acid.
Yes, ma'am. Yeah, exactly.
What was the name?
Phthalic acid.
Yeah, this is phthalic acid. Now this phthalic acid, we are reacting with
Again, what is it, ma'am?
phthalic acid.
P is there, ma'am.
PHTHALIC. Okay. We are reacting with two molecules of ammonia. What we will be getting out of these carboxylic acid groups? We will be getting ammonium salts. Ammonium salt. This is ammonium phthalate. Ammonium phthalate. Now, if we will be heating this, what are we getting? We will be getting amides. So we will be getting CONH2 attached and C attached to it. This is phthalimide. Phthalimide. And if we are doing strong heating of this, we have got this phthalimide. And if we are doing a strong heating of it, what we will be getting, let's open this compound first. It is written like this: NH2 and CONH2. Okay. Now this ammonia molecule will be liberated as a product here. So we will be getting, one of the product is this CONH along with ammonia. So we have added two molecules of ammonia, and in the product we are getting one molecule of ammonia out. So this is how a carboxylic acid, it is converted into amide, okay, on the reaction with ammonia. So this was the third type where cleavage of OH bond takes place. Now the last type where cleavage of OH bond takes place is the process of dehydration. Very simple process. What is dehydration? What is dehydration?
Removal of water molecule.
Yeah, so removal of water molecule takes place, and this we will be studying with two carboxylic acids. And on dehydration of carboxylic acid, we will be getting acid anhydride as a product. Acid anhydride is formed as a product. In this dehydration process, right, these acids are heated with, concentrated H2SO4 or P2O5. These both work as a dehydrating agent. Okay, now I'm taking an example. For example, I am taking two molecules of this acetic acid. Okay, in presence of this P2O5 and heating, yeah, so here, from here, one water molecule will get liberated. If one water molecule is leaving the system, what are we getting as a product? We are getting CH3, CO, O, CO, CH3. What is this? This is acetic anhydride. Acetic anhydride. And water molecule was leaving the system. So if you see here, here also cleavage of COH bond takes place. Clear?
Ma'am, once more, can you say?
Okay. I was saying that we, for acids, to undergo, for an acid to undergo dehydration to form an acetic anhydride, we have to use some dehydrating agents. So the dehydrating agents used here are concentrated H2SO4 or P2O5. These are two dehydrating agents. Okay. For example, I'm taking 2 molecules of acetic acid. Now these 2 molecules of acetic acid, they are reacted with P2O5 in presence of heat, and we are getting an acetic anhydride molecule here. Acetic anhydride molecule from here along with water molecule. So I was explaining the mechanism behind it. We are taking 2 molecules of acetic acid like this. Okay, and as it a dehydration reaction, so we need to liberate 1 water molecule. So we are liberating 1 water molecule like this. Okay, the reagent will be same here, and 1 molecule is being liberated. So we are forming acetic anhydride like this. This is acetic anhydride. Clear?
Yes, ma'am.
Okay. So these were the 4 methods. Now the third type of reaction for carboxylic acid is halogenation. Okay. This is a very important reaction. And how is it done? Just see. This is the third type, reaction of alkyl groups or halogenation. Okay. In this halogenation of alpha carbon takes place. What happens in this reaction? Here our carboxylic group, it is treated with Cl2 or Br2 in presence of phosphorus. This is a key reagent, in presence of phosphorus. Okay, what happens in this? The hydrogen atom of alpha carbon get replaced by halogen atom, as it is a halogenation reaction, means addition of halogen group. So hydrogen atom of alpha carbon get replaced by halogen atom. Okay, and this reaction is also a name reaction. The name reaction is Hell-Volhard. This is an important name reaction, Hell-Volhard-Zelensky reaction. Okay, very important. Hell-Volhard-Zelensky reaction, or we can say that HVZ reaction. Okay, now both of you tell me that, can this reaction take place with HCOOH, this carboxyl methanoic acid? Read these 3
Alpha
points.
carbon is not there, right?
Yeah, very good. Because alpha carbon is not there, so methanoic acid won't give Hell-Volhard-Zelensky reaction. So we will be taking the example of 2-membered carboxylic acid. So I'm taking example of CH3COOH group. We are reacting this with Cl2 in presence of red phosphorus. Okay. Now the alpha carbon will be this carbon. So let's write this like this. Okay. So this is the alpha carbon and this is the alpha hydrogen. We know that this alpha hydrogen is replaced by a halogen group. So halogen here is Cl2. So it will be replaced by Cl group. So what will be the product? The product will be Cl, CH2, COOH. Right? Clear?
Ma'am, last part once more, please.
Yeah. In this reaction, I have told you that what happens, the hydrogen atom of alpha carbon gets replaced by the halogen atom. So I am taking example of ethanoic acid. Here the alpha hydrogen is this, here alpha carbon is this. Now this alpha hydrogen will be replaced by the halogen group. Okay, so I am getting this product. Okay, and the name of this product is chloroacetic acid. Is it clear how the product is formed?
Yes, ma'am.
Okay, Pranavi? Pranavi, is it clear to you?
Yes, ma'am. Clear, ma'am.
Okay. So the product is chloroacetic acid. Now, if you see that this carbon is alpha carbon and it still has two alpha hydrogens. Okay. So we will be replacing these two alpha hydrogens one by one. So until then the point where this compound does not have a alpha hydrogen, we will be doing this mechanism again and again. So again I am doing this step, and again one alpha hydrogen will be replaced by one Cl atom, and the product will be like this. Now this is dichloroacetic acid. Okay, again it has one alpha hydrogen. Again the same step take place, Cl2 in presence of red phosphorus, and the product will be Cl3 CCOOH. Now this is trichloroacetic acid. Okay, so this is the product, trichloroacetic acid. So what are we getting in HVZ reaction? What are we getting? We are getting from ethanoic acid. From ethanoic acid, we are getting trichloroacetic acid. Okay, the type of question that can be framed from this part is either you can be asked the name reaction, what is HVZ reaction, okay, or you can be asked the conversion of ethanoic acid to trichloric acid. Okay, or you can be given this ethanoic acid and trichloric acid as a reactant and product you will be given, and you will be asked with the reagent, that is which reagent we are using. We are using Cl2 or Br2 in presence of red phosphorus. Is the topic clear?
Yes, ma'am.
Okay, now we are left with the last topic, the last chemical reaction of COOH group. Yeah.
Ma'am, what if it is a propanoic acid? Then this reaction won't happen.
Propanoic acid, it will happen. Let me tell you. Okay. What is propanoic acid? It is CH3 Cl2 COOH. Now, if you see that this carbon is alpha carbon, okay, and this alpha carbon has two alpha hydrogens, right?
Yes, ma'am.
So these two alpha hydrogens, it will be replaced by two halogen atoms one by one, depending upon which halogen atom I am taking. Let me show you the reaction. This is propanoic acid, and we are reacting it with, for example, I'm reacting it with Br2 and red phosphorus. Okay. Now, first we will be replacing one alpha hydrogen. This Br is attached here. Now, this reaction will again take place, Br2 in presence of red phosphorus. Again, it will be forming this CBr on both sides, and you will be getting COOH. Okay, or you can say that it is CH3 CBr2 COOH. What is this? This is 2,2-dibromo propanoic acid. Clear?
Yes, ma'am. So except for ethanide, all others will be having
All others will
dibromo.
give. Yeah. The acid which has alpha hydrogen will be giving this reaction. Okay, and the steps will be varying on the number of alpha hydrogens the compound has. Okay.
Yes, ma'am. Okay.
Okay. Now the fourth type of chemical reaction which I will be telling you is the type where reactions involving, if you guys have not noted down the lecture, then I will be forwarding this PDF. Okay, let me know once. Reactions involving COOH group as a whole. Okay, 4 types we will be doing from here. First is the type is reduction. Okay, how reduction takes place? We need to reduce whole of this COOH group. Neither we are studying the cleavage of this OH bond, neither we are studying the cleavage of OH bond. Okay, we have to reduce whole of this compound, and this will be reduced with HI using HI. Okay, what is this HI? This is hydroiodic acid. Hydroiodic acid. So on heating with hydroiodic acid in presence of red phosphorus, temperature will be high, 473 Kelvin. It will be converted into RCH3. Okay, and along with it, water molecule and I2 will be liberated as a product. If you balance the reaction, then we will be getting here 3I2, here 2H2O, and here 6HI. Okay, so this is the reaction where entire COH group is being reduced. Okay, so this is the reaction where COOH group reduces to CH3 group. Okay, this is the first type of reaction where COOH group is reducing as a whole. Now the second type of the reaction is the properties with metals. Okay. CH3 group. Is it clear till now? Any doubt?
No, ma'am.
No, ma'am.
Okay, one more thing. We have already studied about the reduction of carboxylic acids. Okay, when we were doing aldehyde and ketone, we can reduce the carboxylic acid. Carboxylic acid reduces to, what does it reduce down to?
Aldehydes.
Aldehyde. And aldehyde reduces to
Primary alcohol.
alcohol. So if we want to reduce this acid into an alcohol, it will be reduced in the presence of reagent. I have already told, that is lithium aluminium hydride in presence of ether. So with this lithium aluminium hydride in presence of ether, carboxylic acid get reduced down to primary alcohol. Okay.
Okay, ma'am.
Okay, so lithium aluminium hydride reduces the carboxylic acid to primary alcohol. One more reagent I have told you, it was sodium borohydride, right? We were writing as SBH. This sodium borohydride, it does not reduce this carboxylic acid to primary alcohol. Or we can say that it does not reduce carboxyl group. Clear? Only lithium aluminium hydride will be the reducing agent for this. Sodium borohydride will not be reducing it. Okay. Now the second type of reaction where COH group is reduced as a whole is the reaction with salts. For example, we will be studying here the properties of salt, and under these properties of salt we will be studying 4 subcategories. First is with sodium salt. So I am taking a sodium salt of acid, okay, CH3COONA, and we will be reacting it with NaOH in presence of CaO in presence of heat. Now what will be liberating here? COONA will be liberating with NaO. Okay, so what is this forming? This is forming Na2CO3. So Na2CO3 will be liberating along with CH4. Okay. Do you know that what is CaO along with NaOH? What is this? Any one of you? CaO plus NaOH? This is known as soda lime. You must have heard before. Okay, this is soda lime. So what do we say here? We say that the salt or the sodium salt on heating with soda lime, okay, gives hydrocarbon. Okay, clear? If we are taking the sodium salt and if we are reacting with soda lime, then we will be getting a hydrocarbon along with the carbonate of that salt. Okay, the second type in the properties of salt, the second type of reaction is Hunds-Dicker reaction, and this is also an important name reaction. The second type is Hunds-Dicker reaction. What does this reaction say? This reaction says that when silver salt of carboxylic acid, is heated with Br2 in presence of CCl4, alkyl or aryl bromides are formed. Okay, what does this mean? This means that if we are taking silver salt, CH3COOAGs, this is silver salt of carboxylic acid. Okay, if we are taking it with Br2 in presence of CCl4, then we will be getting first alkyl bromide, CH3Br along with CO2 and AgBr. And we can also get aryl bromide. So the reaction for aryl bromide will be like this. This is the first reaction. Aryl bromide will be, I'm taking silver salt of benzoic acid. This is silver benzoate. Okay. This is being reacted with Br2 in presence of CCl4, and we will be getting this bromine molecule will be replacing this COOAG part. Okay, we will be getting bromobenzene along with CO2 and H2O. Is it clear? What is Hunds-Dicker reaction? When silver salt of carboxylic acid, it is heated with Br2 and CCl4, alkyl or aryl bromides are obtained. Is it clear?
Yes, ma'am.
Yes.
Okay. Okay. Now the third type is with calcium salts. Calcium salts. So this is very simple. I'm taking calcium formate. This is calcium formate. How can it be written down? It can be written as this. Okay, this is calcium formate. This part is written like this, and with this calcium is there. This is calcium formate, and this calcium formate on distillation. On distillation, we will be getting HCHO and aldehyde and calcium carbonate. Okay, we will be getting formaldehyde and calcium carbonate. The last reaction and the important reaction is from the properties of salt, it is Kohl's electrolysis reaction. Very important reaction. Just like Hunstetter reaction. Okay, then all the name reactions are very important. It is Kolb's electrolysis reaction, or we can say that Kolb's electrolysis product. What does it comprise of? It comprises of aqueous solution of sodium or potassium. Aqueous solution of sodium and potassium salt on electrolysis give alkanes. Okay, what does happen here? Carboxylic acid gets decarboxylated. How the reaction takes place? For example, I'm taking CH3COONA. I'm taking. This is an equilibrium reaction, and what are we getting? We are getting CH3COO negative and Na positive. So as it was an aqueous solution of sodium on potassium salt. Okay, so this is, what is this? This is sodium salt of carboxylic acid. As it was the aqueous solution, so it get ionized along with the water molecule also. It also gets ionized as H positive and OH negative. Okay, so what does the reactions at anode and cathode, how do they take place? If you know, at anode oxidation occurs. Okay, and at cathode reduction occurs. This you must have studied in the electrochemistry chapter in 11th class. At anode oxidation occurs and at cathode reduction occurs. So how does the oxidation occurs for this? The oxidation will be CH3COO negative. Okay, it will be forming an alkane. I have told you that it will form an alkane. So it will be CH3CH3. Okay, along with two CO2 molecules. Okay, now we need to balance this. So we are putting two molecules of this carboxylate ion. So it will have two negative charge. So to balance this, we are putting two electrons here, negative electrons. For cathode, it will be 2H positive plus 2 electron. It will be forming at H2O. Okay, so what are we getting here? We are getting that this sodium salt of carboxylic acid, it is liberating out hydrogen gas. So this was Kolb's electrolysis process. Okay, now with this, we complete the chemical reactions of carboxylic acid. So we have studied about 4 chemical reactions, 4 types of chemical reactions. Okay, what were they? Can you repeat? First was the cleavage of OH bond. First was the cleavage of OH bond. There we started with the reaction with metals, the reaction with alkalis, the reaction with carbonates and bicarbonates. The second type was the cleavage of COH bond. There we started the reaction of PCl5. With PCl5, we were getting POCl3. With PCl3, we were getting S3PO3. And with SOCl2, we were getting both the gases. So this reaction was the most suitable method for the conversion of acid chloride from acid. The second type was formation of an ester. The third was reaction with ammonia. Okay, and the fourth was dehydration. Now the third type, we studied the reaction of alkyl groups, where we studied about halogenation, and very important reaction we studied, Helmholtz-Zielinski reaction, where the alpha hydrogen was being substituted with halogen atom, right? And the fourth reaction we studied about was the reaction involving COOH group as a whole. Entire COOH group was being converted. So first we studied the reduction of this COOH group with CH3. The second we studied that this COOH group can be reduced to primary alcohol with lithium aluminum hydride, but not with sodium borohydride. The second part was the properties of salt, where we studied about sodium salt, Hundt-Sticker reaction, okay, where silver salt of carboxylic acid along with Br2 and CCl4, it was being converted into alkyl bromide and aryl bromide. Third was with calcium salt, and fourth was with Kohl's electrolysis process. Any doubt?
No, ma'am.
No, ma'am.
Okay.